Hi students, today we are going to observe the FBDs of different numerical problems. Okay, numericals. So in that, let us observe the first question. So for that, let us observe the problem. So this is our ground. Okay, and now I am going to take two blocks. Okay, two blocks I am going to take. One block is having a mass of 10 kg, okay, and the other block is having a mass of 20 kg. Let us take like that. So this is having a mass of first block is having a mass of 10 kg, okay, and the second block is having a mass of 20 kg. So this is the ground. Okay, yeah. Now you observe here two blocks are kept in contact as shown in figure, right? So two blocks are in contact. Two blocks are in contact. In contact as shown in figure. So A, the first question is forces exerted by surfaces. Forces exerted by surfaces. That is the first question. And the second one is contact force between two blocks. Contact force between two blocks. Okay, this is the question. Now we are going to solve it. Okay, come on, let us solve. So in order to solve any kind of system like this, say, and one more thing you take here, there is one force which is acting at 30 degrees, okay, 50 Newton force, 50 Newton force which is acting at an angle of 30 degrees, okay. Now here also 100 Newton is acting, okay. Now we take our normal coordinate system, that is x and y, right? So x-axis can be taken on horizontal and y-axis is vertical. Like this, we are going to use the coordinate system. Okay. Yes. So in order to solve this kind of total system, we are dividing the total system into two blocks, right? Because we are having two blocks. So we are drawing the two FBDs separately. Okay. FBD of 10 kg block I am drawing first. Come on, how to draw? Try by your remote. What you do? Just we are going to take a 10 kg block and you observe what are the different, what are the different forces acting on it? We have to find, right? Yes, very good. Come on, let us take what are the different forces which are acting on it. Okay. So here this is 10 kg. From this end, 100 Newton is acting. Okay. And you know that there will be a perpendicular force. What is that perpendicular force acts on the 10 kg block? Can you guess? Yeah, very good. It is normal force. Can I take this as N1? Okay. Now, downward force, which is the downward force which is acting? Yeah, downward force, that is mg. So here m is 10 times g. Can I take 10g is acting downwards? Okay. And because of this 20 kg, one more force which is acting from this direction, right? That is n2. Yes. Now, what we are going to do? Yeah, we are going to write the equation for this FBD. Come on, let us write the equation. What do we get? So here, how the body is moving? The body is moving in the direction of 100 newtons is acting in this direction, right? So, in which direction? Yeah, N1 is equal to, yes, 10G, okay, which is equal to 100 N. You take this as equation 1. Yes, N2 is equal to N2 and 100 N are opposite. So N2 in this direction only force acting. That's why I took 100 N as N2 as in this direction, no? So in this direction, so N2 as positive, my N2 minus 100 N is equal to 0. N2 is equal to 100 N. Okay, you take this as equation 2. Yes, very good. Now let us draw the FBD of 20 kg block. FBD of 20 kg block. How do we draw this one? So 20 kg block I am taking. 20 kg block. Okay. What are the different forces? You observe here. There is an angle, with an angle, some force is acting. Yeah. Can I take that as this as N4? Because N1, N2, N3, let us take this side, N3 is acting. Okay. And you take this as N4. And N4 is making some angle that is 30 degrees with 50 N. 50 newtons, okay? Yes. Now, this side, no doubt, N2 is acting, okay? And what is the downward force which is acting? So, 20 into N, 20 into G, mg, no? Yeah, 20 into G. Now, we will, somewhat we will modify this in our form because it is making an angle with the horizontal. If it makes an angle with the horizontal, if a force makes an angle with the horizontal, the total force component get divided into two components, right? We already know that. So horizontal and vertical component. Okay. Now what are those two simple components? Let us observe and we will redraw in that form. Okay. We will draw that somewhat clearly. Okay. Yeah. Now this is acting N2. Okay. And this is acting N3. So here N3, can I take N3? This is parallel to the component, right? Yeah. So parallel component can be taken as always. Yes, sine 30. Okay. And then vertical or horizontal or 90 degrees component or perpendicular component that can be taken as, yes, that can be taken as cos theta. So 50 cos 30 and downwards, no doubt downwards 20 kg is acting. Okay. Sorry, 20 G, right? Not kg. Because mg, no, mass is 20. Okay. Here mass 20. Okay. 20 kg we have taken. So 20 into G force is downward force, that is gravitational acceleration due to gravity, it is acting. Yeah. Now can we write the equation? Yes. Come on. Let us write the equation. So N2, because the force is like this, it is moving. N2 is equal to, or N2 minus you can take, so that I am keeping directly because the this force and the forces opposite forces will be equal, right? So here, how much? This is N3 sine 30. N3 means here, can I take directly 50 Newton? So that, yes, so that we can write it easily. Just I'm erasing N3. Okay. So what is our N3 here? N3 is here N3. This is 50 sine 30. Okay. 50 sine 30. Right. 50 cos 30, 50 sine 30. And this is this is N3. You take N3 and this is also in the same direction. Okay. So N2 is equal to, because the force is acting in this direction, you take the body is moving in this direction. Then what happens? N2 is equal to 50 sine 30 plus N3. Okay. Because these two are in the same direction. So we can write either on our LHS or RHS. Now, what about N3? So N3 is equal to, N3 is equal to, how do we write? You see, N3 is equal to, what do we get? Because here 100 minus 25. How much you are getting? That is 75 degrees, right? 75 newtons, sorry. 75 newtons, okay? You take this as equation 3. Now, what do we get? N4 is equal to, in the similar way. What about N4? N4 is equal to, I am writing N4. So this is our N4, no? So N4 and these two are in opposite directions. So can I take N4 is equal to 50 cos 30, 50 cos 30 plus 200. Why? Because 20 G, no, acting 20 into 100, 200. So what about N4 now? N4 is equal to 50 into cos 30 plus 200. Cos 30 is sin 60, no? Root 3 by 2 plus 200. So what do we get? 25 root 3 plus 200. So 25 into root 3. So 1.732. 1.732 into 25. 25 2 is 50. 25 3 is 75, 80. 25 7 is 25 6 is 150. 25 7 is 175. 175 plus 8, 183. Okay. 183. 25 plus 18. 25 plus 18, 43. Okay. 25 plus 18. Oh, sorry. 25 2 is 50. 25 3 is 75. 80. Okay. 25 7s are 175. 175 plus 8, 183. Yeah. 25 1 is 25. 25 plus 18. 43. Yeah. So how much we got? 400 and 433. Okay. 433 plus 200 you are getting. But you observe, is what about N4? N4 is equal to this N4 and this 50 cos 3, both are in opposite directions. So we took like this. So 50 cos 30. Cos 30 is sin 60. Sin 60 is root 3 by 2. 25 root 3 plus 200. So how much you will get? 400 and 200. 433. 1.732. 1, 2, 3 digits. 1, 2, 3 digits. 25 to the 50, 25, 1 0 only, no? 25 to the 50, 25 3 is 75, 80. Yeah, 1, 2, 3, 4.330. Okay. So, sorry, 43.43 point. Here you will get no point, 2 digits. Here one more 0 because 25 into root 3. 25 into root 3, right? So 43.3. 43.3 plus 200. 243.3. Okay. 243.3 newtons. Understood? Yes. Next, let us move to the next question. Find magnitude of force exerted by string on pulley. Okay, you have to find the magnitude of force exerted by string on pulley. So this is the figure they had given. Let us draw the figure first. Here you observe the figure is like this. So the pulley is attached with a thread. The pulley is attached with a thread like this. Okay. And then here also it is totally attached like this. And here there will be 10 kg. Here there is 10 kg weight at down. Okay. 10 kg weight, and it is going to act. There will be, this is our center. From this is the base. So this is 10 kg. Okay. And here also. Okay. Now this is the figure. Now how do we draw the FBD for this? Yeah, FBD. How to draw the FBD? First, here the mass is 10 kg block. Okay. So 10 kg block we are going to take. Yes. After that, next what you do? Yeah. You have to observe the normal, because here you observe because there is a string. So there should be a tension, no? Yeah. Tension is acting upwards, right? And acceleration due to gravity downwards, that is same force mg, that is 10g can I take. Okay. Now this is our figure. Now what you are getting? So tension T, how the body is moving? The body is moving upwards. The body is moving upwards. T minus, so this is the acceleration position, right? The body is moving upwards. So T minus 10g is equal to 100 newtons. Okay. T is equal to 10g is equal to T is equal to 10g is equal to T is equal to 10g is equal to 100 newtons. Okay. Yeah. You can take like this. Now, if you draw the FBD of pulley, let us draw the FBD of pulley. So, in order to draw the FBD of pulley, let us draw a circle first. And then we are going to observe the what are the different normal forces, what are the different forces those are acting, you have to observe, no? Yes. So this is N1 and this is N2. Okay. And here 100. Okay. Next, this is, you take this one, this becomes the resultant, no? Yes. So this is 100. So this will be the resultant. Okay. Now you take this one as N1, N2 and 100. If you take this as XY, okay, X and Y. Now here you observe the string is massless, no? Because the string is massless. That is massless string. Okay. So tension in both sides of the string should be same. So tension in both sides in both sides should be same. Should be same, right? Yes. Now, so what about the net forces? Because tension in both sides should be same means the same forces are acting. So what about the net force? So net force is totally zero, right? So net force is net force. Net force. Net force is zero. Okay, zero. So what are they asking? Force exerted by hinge. So what about the force exerted by the hinge? They are asking. So the force exerted by the hinge is nothing but the resultant vector, right? So our resultant vector 100, 100. For these two, you have to take the resultant. So how do we take the resultant according to the vector rule? We can take root of x square plus y square, right? So 100 square plus 100 square. How much you are getting? 100 into root 2 newtons. Yes, understood. So in this way, we can solve the numerical by taking FBD by drawing the FBD of different blocks, and then we can write the equation and we are going to solve. So what is the main thing here? The main thing is how the body is moving. If the body is moving in a particular, say the body is moving in this direction, so T, whatever the forces which are present in that direction to be positive, whereas the remaining forces should be negative. In that way, you follow this kind of, what do you say, FBDs, then you can easily do any kind of question. Okay. In next video, I am going to take some numericals and then we will solve some numericals which are related to these kind of FBDs. Okay. Thank you.